Hello everybody, welcome into another lesson. So today we are going to solve right triangles with right triangle trigonometry. So yesterday we did use some Pythagorean theorem to solve right triangles to find a missing length, and then we found the 6 values of an angle for trigonometric functions. Well, today we're going to put those to use. So here you have triangle ABC, that's a right triangle, and all the triangles today will be a right triangle. You have sides A, B, and C, where side A has a length of 8. You don't know B, you don't know C, so you only know the length of one side. And they give you that angle B is 24 degrees. So we need to find the measure of angle A as well as the lengths of sides B and C. Well, we know it's a right triangle, don't we? So we actually already have two angles. And if we remember from geometry, the other two angles of a right triangle are complementary to each other, meaning they add up to 90 degrees. So that means the measure of angle A is equal to 90 degrees minus 24 degrees, which means the measure of angle A itself is going to equal 66 degrees. So we already found the missing angle, the measure of angle A. Now, we need to find sides B and C. I'm going to suggest let's find side B first. So we know side A is 8. Side B we don't know. Well, side A with 8's the adjacent side, right? Side B is the opposite side. Is there a relationship between adjacent and opposite side? There sure is. There's the cotangent, right? If we take the cotangent of 24 degrees, that's going to equal your adjacent side of 8 all over B. Or it actually might just be easier to use tangent. I don't know what I was thinking. Opposite over adjacent is tangent. Why don't we do that? That'd make more sense. So we have the tangent of 24 degrees equals opposite over adjacent. That'd be B over 8. So opposite over adjacent's the tangent. So that means side B is going to be equal to 8 times the tangent of 24 degrees. And now we can get a decimal approximation. So make sure your calculator is in degrees instead of radians. In 2 lessons from now, we'll get into radians and what those are. But it's very important that your calculator be in degrees. So let's take the tangent of 24 degrees times 8. That gives you a length of about 3.56 if we round to 2 decimal places. So side B has a length of approximately 3.56 when you solve this. Now we can find the hypotenuse side C. So my suggestion is we don't use the side we just found since we had a decimal approximation. You'll get a relatively accurate approximation of the hypotenuse, but you're better off to go with the side you were given, okay? So adjacent over hypotenuse, what's that? What relationship is that trig function wise? That's the secant. So the secant of 24 degrees equals the hypotenuse over the adjacent, rather. Yeah, hypotenuse over adjacent, secant of 24 degrees equals C over 8, which means C is going to equal 8 times the secant of 24 degrees. However, most calculators only have sine, cosine, and tangent. They don't have secant, cosecant, and cotangent. So how can we rewrite this so we can calculate it? Well, isn't secant the same as 1 over cosine? It's the reciprocal of cosine, right? So this is the exact same thing as 8 divided by the cosine of 24 degrees, which now we can get a decimal approximation of the hypotenuse. So let's find that cosine of 24 degrees. Let's take 8 and divide it by that answer. You get about 8.76. So the hypotenuse C has a length of about 8.76 when you do the calculation. And I got more examples here. Let's see what we got this time. Let me fill this in temporarily. Whoops. I don't want to keep that value up because that may not be true on the next one. Alright, we're given that angle A has a value of 37 degrees. We're given that the hypotenuse C has a length of 22. So we know angle A is 37 degrees. We know the hypotenuse C is equal to 22. Alright? Well, we don't know angle B just yet, but that's the easiest thing to find because the two remaining angles of a right triangle are complementary. So the measure of angle B would equal 90 degrees minus 37 degrees. So that means the measure of angle B would have to be 53 degrees. So angle B is 53 degrees. So we found that angle. We solved for the angles. Now we need to find the sides. I'm going to say, let's find side A first. Let's go in alphabetical order. Alright, so side A is your opposite side, and we know the length of the hypotenuse. Is there a trig function that recognizes the relationship between the opposite side of an angle and the hypotenuse? The sine function, right? If we take the sine of 37 degrees, that's going to equal our opposite side of A all over 22, which then means that A equals 22 times the sine of 37 degrees. So now we can get a 2 decimal place approximation for A if we put in that value. So let's see, sine of 37 degrees, we get that times 22. You get about 13.24. So side A has a length of approximately 13.24 units. Now, what about side B? So side B would be the adjacent side to angle 37, the angle of 37 degrees, right? Well, is there a trig function that recognizes the relationship between an adjacent side and the hypotenuse? Yeah, the cosine function does, right? So the cosine of 37 degrees is going to equal that adjacent side B over your hypotenuse, which is 22. So B would equal 22 times the cosine of 37 degrees, which now we can get a 3 decimal approximation for side B. So let's go ahead and do that here. You get about 17.57. So B has a length of approximately 17.57. That's about what you would get for side B. And I got more. I have about 6 more here. Today's lesson should be relatively easy. Tomorrow we get deeper a little bit into trig. The next lesson, I should say, hopefully tomorrow, barring nothing comes up. Alright. Let's see what we got here. We got angle A this time is 19 degrees. We got that side B equals 4. Alright, so we are given this triangle where angle A is 19 degrees, side B equals 4. We don't know the other two sides or angle B, but angle B, all we got to do is take 19 from 90. So the measure of angle B equals 90 degrees minus 19 degrees, which has to mean that the measure of angle B is going to equal 71 degrees. So we found the measure of angle B. Let me get a new black marker. Alright, so we got angle B. Now let's go for side A. Let's work in alphabetical order. Well, is there a relationship between the opposite and the adjacent side, since those are the sides we're working with? Opposite over adjacent, that's the tangent function, right? So if we take the tangent of 19 degrees, that would be equal to your opposite side of A over your adjacent side of 4, which means A would equal 4 times the tangent of 19 degrees. So now we can proceed to get a decimal approximation to 2 decimal places. So let's find that. We get that A is approximately equal to 1.37. So side A has a length of approximately 1.37. So now we can try to find side C. So look at the 19 degrees again, all right? Side 4 is the adjacent side. Is there a relationship between the adjacent side and the hypotenuse? Well, if we did hypotenuse over adjacent, that would be the secant function, right? So we can take the secant of 19 degrees, which would be equal to that hypotenuse of C all over 4, which means C equals 4 times the secant of 19 degrees, which, in order to put this into your calculator, we need to convert secant into its reciprocal function. So this would be the same as 4 divided by the cosine of 19 degrees. And then we should be able to get a 3 decimal approximation for C. So let's see, cosine of 19, we get that. Take 4, divide by that. You get about 4.23. So the hypotenuse C is approximately equal to 4.23 in this case. All right, I have about 5 more. All right. So angle B has a measure of 41 degrees. Side C, or hypotenuse, has a length of 18. All right. So we got this right triangle where angle B has measure of 41 degrees. Your hypotenuse has a length of 18. First, again, let's solve for angle A. The measure of angle A, since this is a right triangle, is simply going to be 90 degrees minus 41 degrees, which means that the measure of angle A would have to be 49 degrees. So we just found the measure of angle A to be 49 degrees. All right, now let's start with side A. Let's go in alphabetical order. Is there a relationship between the adjacent leg and the hypotenuse? Yeah, the cosine, right? The cosine is adjacent over hypotenuse. So if we take the cosine of 41 degrees, that's going to equal your adjacent leg A over your hypotenuse 18, which means that A would equal 18 times the cosine of 41 degrees. So now we should be able to get a 2 decimal place approximation of A. Alright, so cosine of 41, take that times 18, you get about 13.58. So A has a length of about 13.58 units. Now let's find side B. Is there a relationship between the opposite side and the hypotenuse? Yeah, that's the sine function, right? So that means the sine of 41 degrees equals side B over the hypotenuse of 18, which means B is going to equal 18 times the sine of 41 degrees, which now we can get a 2 decimal place approximation if we calculate this. And once again, I want to remind you, please make sure your calculator is in degree mode. So we got sine of 41, take that times 18, you get about 11.81. So B has an approximate value of 11.81 units. So those are what you would get for this triangle. Now I have 4 more, then we'll be done. All right. Let's figure out what we got next. Angle A equals 29 degrees. So this case we have angle A. Side B has a length of 21. All right. Yep. So we know in this triangle, angle A equals 29 degrees. Of course, it's a right triangle. Side B has a length of 21. We don't know angles B or sides A and C. Well, angle B is the easiest thing to find. To find angle B, all we have to do is subtract 29 from 90. So 90 degrees minus 29 degrees would have to mean that the measure of angle B would equal 61 degrees. So now we found the measure of angle B to be 61 degrees, okay? Stupid pop-ups. All right. Now, let's see, let's go for side A. So you know the adjacent side, 21, but you don't know the opposite side, side A. Is there a relationship between opposite over adjacent? That's the tangent function, right? So if we take the tangent of 29 degrees, that would be equal to the opposite side of A all over your adjacent side of 21. So that means A would equal 21 times the tangent of 29 degrees, which now we can get a 2 decimal place approximation. All right, take that value times 21, you get about 11.64. So A is approximately equal to 11.64. Now we can find C. So is there a relationship between the hypotenuse and the adjacent side? More so the hypotenuse over the adjacent side. Once again, that's your secant function. If you take the secant of 29 degrees, that's going to equal your hypotenuse of C over your adjacent side of 21, which means C would equal 21 times the secant of 29 degrees. But in order to be able to calculate secant, we got to make it in form of its reciprocal function cosine. So that means C would equal 21 divided by the cosine of 29 degrees. Now we can get a 2 decimal place approximation for this. So let's go ahead and figure this out. You get about 24.01. So C has a length of approximately 24.01 units. And I got 3 more. All right. Let's see here. So B has a measure of 56 degrees. And then A is 6.8. All right. So we have a right triangle where measure of angle B is 56 degrees, side A equals 6.8. We don't know measure of angle A, we don't know sides B or C. But the angle A is easy to find. To find the measure of angle A, you'll take 90 degrees and subtract 56 from that, which means the measure of angle A can equal none other than 34 degrees. So we found the measure of angle A to be 34 degrees. Now let's work on our sides. So you know the adjacent side to the 56 degree angle, which is 6.8. We don't know the opposite side, B, but we know tangent is opposite over adjacent, right? So that means we can take the tangent of 56 degrees, set that equal to your opposite side, B, divided by your adjacent side, 6.8, which then means that B equals 6.8 times the tangent of 56 degrees, and now we can get a 2 decimal place approximation. So let's go ahead and figure that out. Take that times 6.8. You get approximately 10.08. So side B would have a length approximately 10.08. Then we can proceed to find the hypotenuse. So let's say then, all right, we have the adjacent side and the hypotenuse. Well, we know hypotenuse over adjacent is the secant function, right? So that means the secant of 56 degrees equals your hypotenuse C over your adjacent side of 6.8. So C would equal 6.8 times the secant of 56 degrees, which means C equals 6.8 divided by the cosine of 56 degrees. So now we can get a 2 decimal place approximation for that. That would give you about 12.16. So the hypotenuse C has a length of about 12.16. And I got 2 more. Let's erase what's up here. All right. Angle B is equal to 65 degrees. Your hypotenuse C has a length of 12. All right, so this right triangle, angle B has a measure of 65 degrees. The hypotenuse has a length of 12. We don't know angle A, we don't know sides A and B. Well, that's okay. We can find angle A if we just subtract 65 from 90. So the measure of angle A equals 90 degrees minus 65 degrees, which then would have to mean that the measure of angle A equals 25 degrees. So there's one part of this right triangle solved. So the measure of angle A equals 25 degrees. Now let's find side A. So the hypotenuse is 12, A is adjacent to 65. Well, we know cosine is adjacent over hypotenuse, right? So that means the cosine of 65 degrees would have to equal your adjacent side A over your hypotenuse 12. So that means A is going to equal 12 times the cosine of 65 degrees, which now we can get a 2 decimal place approximation for this. So you would get about 5.07. So side A has a length of approximately 5.07. Now what about B? Well, again, we know the hypotenuse, but we don't know the opposite side. But sine is opposite over hypotenuse, right? So if we take the sine of 65 degrees, that's equal to your opposite side of B over your hypotenuse of 12. So B would equal 12 times the sine of 65 degrees, which now we just compute this, we can get a 2 decimal place approximation for our answer. So let's see what we come up with. You get about 10.88. So side B has a length of approximately 10.88 units. So there's all the missing values for the sides and angle A. I got one more example. All right, that's side C. There we go. One more. All right. Measure of angle A equals 70 degrees. Side C, your hypotenuse, is 30. Alright, so the measure of angle A is 70, your hypotenuse is 30. We don't know the measure of angle B or side A and side B. That's okay. To find the measure of angle B, you're just going to subtract that 70 degrees from 90, so that equals 90 degrees minus 70 degrees, which means that the measure of angle B would be equal to 20 degrees. So we just found the measure of angle B to be 20 degrees. Okay, now let's start with side A. Opposite over hypotenuse, that's going to be the sine function, right? So if we take the sine of 70 degrees, set that equal to your opposite side of A over your hypotenuse of 30, that means A is going to equal 30 times the sine of 70 degrees. Now we'll just calculate this and we'll get a result to 2 decimal places. You get about 28.19 for side A. So side A has a length of approximately 28.19 units. Now let's figure out side B. Side B is the adjacent side, so adjacent over hypotenuse, that's the cosine function. So the cosine of 70 degrees would equal your adjacent side of B over your hypotenuse of 30, which then means that B equals 30 times the cosine of 70 degrees, which now we can get a 2 decimal place approximation for side B. Alright, cosine of 70, take that times 30, you get about 10.26. So side B would have a length of approximately 10.26 units. So that's how you use trigonometry to solve right triangles, find the missing sides and missing angles. The next lesson we're going to get into general angles. This is where you're going to find out that angles can actually be greater than 180 degrees. Up till now, through all your previous courses and up till this point, you've been taught that angles go up to 180 degrees. They actually go well beyond that. And we're going to explore that in the next lesson. And we'll talk about coterminal angles, initial sides, terminal sides, all that stuff. And we'll even talk about negative angles, which angles can go negative too. So I hope everyone has a great day. Take care.